Welcome to class 10 science. We were discussing chapter 5 periodic classification of elements. In this video we will discuss about trends in modern periodic table with respect to valency, atomic size, metallic and non-metallic properties. First come to valency. Combining capacity of an element is called its valency. Valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. We can say valency is equal to number of valence electrons, or valency is equal to 8 minus number of valence electrons. For example, valency of magnesium is 2. How? As we know, atomic number of magnesium is 12. If we write its electronic configuration, it will 282. These 2 are the number of valency electrons. That's why its valency is 2. Now, valency of sulfur is 2. Atomic number of sulfur is 16. If we write its electronic configuration, it is 286. Then we can say this is 8 minus 6 is equal to 2. This table shows the valency of some elements like hydrogen is 1, helium is 0, lithium is 1, beryllium 2, boron 3, carbon 4, nitrogen 3, oxygen 2, fluorine 1, neon 0, sodium is 1, magnesium 2, aluminum 3, silicon 4, phosphorus 3 or 5. Sulfur 2, chlorine 1, argon 0. Variation of valency in groups and in periods of periodic table. First see groups. These are the some first group elements: lithium, sodium, potassium, and electronic configuration of lithium is 21, sodium is 281, potassium is 2881, and from these electronic configuration we can find out valency electron, that is 1. That's why valency of group 1 element is 1. Now these are the some group 2 elements: beryllium, magnesium, calcium. Electronic configuration: beryllium 22, magnesium 282, calcium 2882. If you find out number of valence electron in all these elements, these are 2. That's why valence is 2. In group 17 elements, fluorine, chlorine, bromine, electronic configuration is 27 for fluorine, 287 for chlorine, and bromine 28187. And we can find out valence electrons in all these elements 7. That's why valence is 8 minus 7 is equal to 1. Now what we conclude from these observation, that elements present in the same group have same valency. Clear? Because they have the same number of valence electrons. Now come to the period. These are the second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And electronic configuration of these elements: lithium is 21, beryllium 22, boron 23, carbon 24, nitrogen 25, oxygen 26, fluorine 27, neon 28. And with the help of this electronic configuration we can find out the valency. Lithium is 1, beryllium 2, boron 3, carbon is 4, nitrogen is 3. How 3? 8 minus 5. These 5. Okay, 8 minus 5, 3. Oxygen 2, fluorine 1, neon 0. The same way, these are the period 3 elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. And electronic configuration: sodium 281, magnesium 282, aluminium 283, silicon 284, phosphorus 285, sulfur 286, chlorine 287, argon 288. Now if you find out the valency with the help of these electronic configuration: sodium is 1, magnesium 2, aluminium is 3, silicon is 4, phosphorus 3 and 5, sulfur 2, chlorine is 1, argon is 0. I think you can find out the valency of these elements if you know the electronic configuration. That's why we can conclude, in group, elements present in the same group have same valency. And in period, generally valency increases and then decreases in a period on going from left to right. You can see this is increases up to 4, then this is decreases. Atomic size. The term atomic size refers to the radius of an atom. The atomic size may be visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. You can see in this diagram, this is the center of nucleus and this is outermost shell. Distance between this is referred to atomic radius. Okay, and atomic radius gives idea of atomic size. Generally, atomic radius of hydrogen, not generally, this atomic radius of hydrogen atom is 37 picometer, and 1 picometer is equal to 10 raised to the power minus 12 meter. Variation of atomic size in a period. Atomic radii of the elements of the second period are given below. These are the second period elements and these are their atomic radii. Boron is 88, beryllium 111, oxygen 66, nitrogen 74, lithium 152, carbon 77. Now, elements in decreasing order of their atomic radii. On the basis of these radius, arrange these elements in the decreasing order. You can say lithium is maximum, and then beryllium is lesser, then boron, carbon, nitrogen, oxygen is smallest among these elements. Okay, and now if you compare this order, then you can see that this is the same order in which elements are present in second period on going from left to right. In second period, if you go from left to right, this is the same order: lithium, beryllium, boron, carbon, nitrogen and oxygen. Which elements has the largest and the smallest atom? You can see largest is lithium and smallest is oxygen. That's why we can say atomic radius decreases, okay, as we go from left to right in a period. Now, what is the reason? This is due to an increase in nuclear charge, which tends to pull the electrons closer to the nucleus and reduces the size of the atom. We have discussed the electronic configuration of these elements. In these elements, number of cells remains the same, okay, and electron enters in the outermost cell by 1 unit. In this way, effective nuclear charge is increases. That's why size is reduced if we go from left to right in a period. Now, variation of atomic size in a group. Again, atomic radii of first group elements are given below. Sodium is 186, lithium 152, rubidium is 244, cesium 262, potassium is 231 in picometer. Now again, if we arrange these elements in the increasing order of their atomic radii, then we can say lithium has smallest atomic radius and cesium has highest. Now again, you see if this order, we can say this is the same order in which elements are present in first group on going from top to bottom. Is it clear? In a group, we will compare from top to bottom. In a period, we compare from left to right. And again, name the elements which have the smallest and largest atoms. We can say smallest is lithium and largest is cesium. That's why we can conclude atomic size increases, clear? Increases as we go down a group from top to bottom. Now, what is the reason? This reason is because new cells are being added as we go down the group. As we go down the group, number of cells are increases. This increases the distance between the outermost electrons and the nucleus, so that the atomic size increases in spite of the increase in nuclear charge. Now we can say nuclear charge means number of protons are also increases, but the increase in size is more compared to the increase in nuclear charge. That's why overall result is atomic size is increases top to bottom in a group. You can see variation of atomic size in period and in a group. This is a group. This is increases from top to bottom, and this is a period. This is decreases from left to right. Okay. Now metallic and non-metallic properties. Again, if we write the third period elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, and their electronic configuration: 281, 282, 283, 284, 285, 286, 287, 288. Now if you find out their metallic and non-metallic character, then we can say sodium, magnesium, and aluminium, these are metals. Silicon is metalloid, and from phosphorus to argon, that is phosphorus, sulfur, chlorine, and argon, these are non-metals. Now what we conclude from this observation, we can say that metals are towards the left hand side of the periodic table, while non-metals are found on the right hand side. Okay. In the modern periodic table, a zigzag line separates metals from non-metals. You can say this is the one part of this modern periodic table, and in this case, this is a zigzag line. Okay, and these are the non-metals, and at the left hand side, or we can say at the left hand side, these are metals. And only these borderline elements, like this is boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. These are intermediate in properties and are called metalloids or semi-metals. Okay. Variation of metallic properties in a period and in a group. Metals tend to lose electrons and form positive ions while forming bonds, so they are electropositive in nature. Okay, we have discussed the formation of ionic bond. In that, ionic bond is formed between the metal and non-metal, and metal lose the electron and form positive ion. That's why metals are known as electropositive elements, and they are electropositive in nature. Across a period, that is, if you go from left to right in a period, the effective nuclear charge acting on the valency shell electrons increases, so the tendency to lose electrons will decrease. But down the group, that is from top to bottom, the effective nuclear charge experienced by valency electrons is decreasing because the outermost electrons are farther away from the nucleus. Therefore, tendency to lose electrons will increase. Hence, we can say metallic character decreases across a period and increases down a group. This is the trend of metallic characters. Now, variation of non-metallic properties in a period and in a group. Non-metals tend to form bonds by gaining electrons, so they are electronegative in nature. The tendency to gain electrons increase as we go from left to right across a period and decrease as we go down a group. As the trends in the electronegativity show, non-metals are found on the right hand side of the periodic table towards the top, right hand side, and at the top. This is the right hand side of the periodic table, and this is the top. Clear? These are the non-metals, and we can say that is a non-metallic characters are increases from left to right in a period and decreases in a group from top to bottom. And one more thing, in the that is, we can say in metals and non-metals chapter, we have discussed that in general oxides of metals are basic and oxides of non-metals are acidic in nature. Okay, student, now this chapter is completed. Subscribe my channel to get the new videos of next chapter.